Hello, everyone. I'm going to give you a run through of our week 5 content for prompt engineering. Again, this is now our second week working in Python. And so I want to make sure that you see a little bit of how I navigate through it. And that way, if you have any questions, you can reach out to me in addition to watching me go through some of this content myself. One thing I want to start out with is I realized in last week's practice, there was one line where I didn't actually have the print statement. So I had the code correct, so nothing was wrong in the code. At the end of this hello world, I added in a variable called lower, where I took the variable called my text that you see I defined up above. So my text here on this second line, we define as the string. This line prints a sentence. So if we just run this, I'm going to comment out for a second the rest of this. If I just run these first 3 lines of code, here's what we get. So we have our hello world statement. Let's comment that out as well. So if we just print my text, we define my text, and then we print my text, this is what we get. When we now take it and make it as lower, I'll show you what this does. This now runs this code for lower. So it's creating a new variable, no longer called my underscore text, but the new variable is called lower. I'm going to delete this here for a second. So we have the variable called lower, where we take the string, the name of the string is my underscore text, and one of the pre-built functions in Python allows us to put a dot and then the word lower with parentheses open, close directly after each other. And what that does is that makes whatever's in the string into lowercase. I'll show you another example. Well, here, let's run this first. So now let's print lower, and this is what we get. So we have the lower version of it where it's all lowercase, and we can do the same thing with upper. Let's just do upper equals my text dot, my underscore text dot upper, print upper, and then we get the same thing into all caps. Let me just go on and add a new chunk of code. Let's do another one called hello world. So we had that, and let's define this as hello, comma, world. So we have hello world, we can print hello world. There we go. But the other thing I can do now is I can either make these separate variables. And again, if I use the word lower or upper, this is just a variable that's already defined. So it has in it the definition of whatever my text is. So we can either, let's make it, let's do it a different way. Let's do print hello world. So just like I said, when we defined it, we can put a dot, and then now we do lower with parentheses. So it's the inner parentheses attached to the dot lower that just tell it take the string that's called hello world. And if I hover over it, you can see what we called hello world. It's this statement. So watch what happens when I do this. Now it's all lowercase. And I can do the same thing for hello world.upper and print that as well. So this is just one feature that you may or may not wind up using this semester, probably not this semester, but if you go on to do anything more in Python, especially there are courses that we offer at ASU in problem solving with Python, or anything in the information technology department or computer science department. Anytime you want to create a game that requires this, it's often useful to be able to control whether something is lowercase or uppercase. So for instance, you might do an input variable where you ask a user to type in their name. And sometimes you want to make sure that no matter if they're typing in lowercase or uppercase, that it treats it the same. So a great example is here where I have print Q to quit. I kept this code simple, so I didn't put any validation in here. Uh, Actually, I did. I'll show you right here. So this dot lower takes the user input, So this is what I ask the user to type in. Okay, either give me your next number or type the letter Q. So when it's taking user input, it's defining that as whatever the user enters in under input. So if the user types in the letter X, it's going to not know what to do with that. So either this accepts a number, an integer, or it accepts the letter Q. But this lower, dot lower, makes it where if the user types in capital Q, I'm automatically translating it into lowercase. So it will match what we have and it will continue to work. So again, that's just a more advanced insight into it. You don't need to know how to do that, but I just wanted to show you what that looks like. Um, Again, this is from last week, so I'm going to go ahead and save this so that way when you look at the code, you have it there as well. But that's dot lower and dot upper to make something into either uppercase, lowercase, or uppercase. Let's go back to week 5. You have the data camp tutorial. So for this, I'm only requiring chapters 3 and 4. Chapters 1 and 2 are optional. There's more overlap with the Python for Developers tutorial on there, so you're welcome to skip those. But chapters 3 and 4 cover more new material, so I do want you to go through and do those at a minimum. It's always good practice to do everything if you'd want it, but just know that I'm only grading you on completing chapters 3 and 4 for this week. So a couple of things. We have a Python tutorial with Google Colab. That's actually the optional link that I gave you here last week. We'll go through and look at some of the important aspects of that I want you to see. And I'll also show you our first homework assignment where you're actually now using Colab and using Python. So this assignment is our first, I'm calling it experiment in prompt engineering. It's called Brewing Success, is just the name of the case study. And so this instruction sheet walks you through everything you need to know. One thing to emphasize is that I don't want you to just copy and paste my instructions into ChatGPT. I want to see, and I'll grade you on your own human creativity. So I want you to take each of the steps of what I'm asking you to do here in this activity and then open up your own browser, your own AI tool, either ChatGPT or Gemini or Claude. I really like Claude for writing Python code, but try it with any of those three, and you can experiment as we go throughout the semester as well. And so what I'm grading you on is I want to see the prompts that you come up with to be creative in try to understand what it is that I'm asking you to do, and then you take that, process it, and ask AI to do it for you. So you are going to be using AI tools, but I want to see not just what the AI can come up with, but I want to see your way of you prompting it, you giving it context for what we're trying to do. So part 1 of this is to open this Colab notebook. So if you go ahead and click open Colab notebook, you'll also, just like last week, need to do file, save a copy in Drive. So you can actually do your work in your own copy of the notebook. So this is my copy that I am the owner of this document. But if you go to save a copy in Drive, it'll then let you make a copy so that way you can make your own edits and save your own changes in here. And then you'll turn this in as your first assignment. So this goes through and gives you some ideas on getting started in Colab. This gives you here an introduction to the assignment. So the actual task of what we're going to be doing here of making a business decision based off of the data that we have. This is a useful thing for setting up your environment. The first time you're working in Google Colab, there's a few packages to install onto your machine or onto your environment of Google Colab that you'll just click that link, and that's actually right here. So I'm going to get started with that, clicking that line to run, and then it goes ahead and runs it there. So that's going to run in the background, and that will set your packages up just so you have them available to you. And then you go through, and what you'll do is you'll go through each step here. Some of this I showed you how to do last week, like how to run a chunk of code in Google Colab in a cell. You just click this run arrow. So go through, read these instructions carefully. Um, this first one here is just reading in the data file. So I've uploaded the data file. I'm not expecting you to download data and put it on your own machines and learn yet how to upload data and read in data. We'll keep it simple where I'll just give you the URL. I'll give you the website where I'm hosting the data file. This is a CSV, comma separated variable file. It's like a type of Excel file, like XLS or XLSX, same thing, with less formatting and kind of cleaner data in a CSV file. So you'll go through and do that. You'll run that. And then this image that I have here is the expected output. So if everything is working on your machine and you're able to execute this line of code, let me just do that for you right here. You'll see now I have not just an image of it, but I have the actual data frame where the data is read in, is what it's called, into here. So the data worked. It looks like this table that I have down here. If you see the numbers, they're the same, 152, 6.74, 14, etc. So that first step for me was successful. You can learn more about the data itself at Kaggle. You can go to this website and start to explore what the data means. I've given you some of the basics of what data variables, columns in here represent. So you'll go through and this is your first assignment is to complete this. So you'll read these steps. When I have these two chunks of code here, what you should do here is you'll work with AI to generate Python code. So the first thing I want you to do is you can just replace this and put your actual Python code into this box where it says paste in your code here. So you can totally delete this completely and then just type in or copy and paste in your code. What I want you to do in here, and it's important that you can just highlight this, leave these quotation marks. That just makes this whole box a comment. So the comment is anything that's in between these quotation marks. So it won't actually execute this code. But you can still have this comment here. You can still execute and run this cell. But the part that you're running to get the output is the code itself. So your code, just look at what I have here. Code is here. ChatGPT prompts are down below. And again, leave those quotation marks, and that will keep it as a comment for me. That way, I'm grading you also on the creativity of your prompts. And if we run into any issues where you get a wrong result, we can go back and try to fix what your prompts were. So that is the same model that we'll do for a couple things here. And then just continue reading this and you'll be able to see what the expected output looks like. So you should get something that looks like this. And I tell you, if you didn't, then you can double check it. And I give you a way of taking it and asking for what it already is looking for. So part 4 is an optional question. You might have already fulfilled it in part 3. So that's what this sentence is saying here. If your previous code already calculated a Pearson correlation coefficient and gave us a scatter plot, move on. So you can skip part 4. But if you did not get the correlation coefficient, which should be 0.25 approximately, and if you didn't get this scatter plot, then do part 4. Part 4, I'm just giving you some more specifics of what to ask for. Finally, part 5 is now in your own words. How do you interpret what Pearsons are and the p-value represent? So you're welcome to use AI tools to ask about it, but I do want you to write in your own words, not in AI's words, what these values actually represent. So when we said 0.25, what does that mean? When we say a p-value which is close to 0, this notation here, the 5.1983, e to the negative 31 means we move the decimal point 31 places back to the left. So it's saying it's 0.00000 keep going kind of 31 decimal places out. So it's practically zero. This p-value means zero. That's what we interpret this as. What does a p-value of zero or really, really close to zero represent? So have the conversation with AI tools, but then feel free to, or you're expected to then put that into your own words. And I give you some hints over here of what that looks like. Um, and then here, this part is a little different than the others because I want you to generate text. You can actually double click where it says here, or it said to double click here, and you actually put your text in right over here. Finally, reflecting on the assignment. This is the biggest part of your grade on this assignment is what I care about is what was this experience like for you? So this is your first opportunity to actually engage with the prompting that we're going to do in class. This is kind of in a light, easy introduction to it where I kind of walk you through a lot of what you'll need to do. I try to make it as simple as possible for you. And so you're going to go through and just answer these questions. So there's 4 big picture questions, and I have some initial other kind of follow-on questions to think about as you look at each section of this. So you can again click where it says double click to edit and type in your responses there. Finally, I give you steps on how to share your document, just like any other Google Doc. If you go to share up here in the top, share notebook, you can then share it to anyone with the link. So you can change general access, you'll see, and this is what it looks like, to anyone with the link. Then when you copy the link as viewer, I will be able to then see when you submit that URL to Canvas, I'll be able to see it and grade your work. So there's some more details here if you want it, some additional challenges to take on. Totally up to you, not required for the course, not extra credit, just if you want some additional enrichment, here it is. I'll show you one other piece to this that is totally optional, but if you do want to participate, I am conducting research on students' responses to AI. And so feel free to take a look at this. And this will, if you want to share the results of your responses, your questions at the end, those reflections, this will only improve what we do here at the Polytechnic School and how we teach AI related topics. And this will be anonymous and separated from your own information. But if you are interested in sharing your results, you'll just click this survey to give me permission, and then I'll pull your responses anonymously without your name. It won't be stored with your name or any other identifying information, but it will help us improve what I'm doing here at the Polytechnic School, along with my colleagues, on how we can best support our students. So that explains that. And again, I just put the reflection prompts in here. You can do it in any format, but the important thing here is I do care about what you have to say, not what AI has to say. So this is a place where you may not use AI to write your reflection. This is where I want to hear your initial thoughts, your own original thoughts on what the experiment was like of the going through this assignment for the first time. So that is that assignment. I do want to show you one other way just of how I use AI in my workflow. If there's ever a piece of code, which I'll show you where this comes from here in a minute, where you want to understand what each line of the code represents, you can just ask it, kind of break it down for me and tell me what this code represents. So this is an example just how I did it. We'll see this when we get into the Python tutorial. But this was, I just asked it to explain this chunk of code. So the first line, I'll just walk through and kind of explain it along with the AI explanations here. So when we run something, a variable, so this is we're assigning a new variable, and then we're putting it in square brackets. And you'll see each element of this list is what it's called. The list is in quotation marks, single quotes here. And so you'll put each element in. And what it does is it creates an ordered collection of items. So it's saying, okay, the first element of the list is called cat. Second element of the list is dog. Third element of the list is monkey. And these are string variables. So the important part is actually what's in the quotation mark. So that's what that first line does. Second line is a for loop. So this is a for loop where it's starting with the list that we had called animals. And then it's cycling through. And this is actually defining each of these elements as something called the variable animal. So it's setting up the variable animal. And then what it does is it's cycling through that bigger list called animals in the plural and assigning each of the animals to an instance of the specific animal that we have here. So we start a for loop. The for loop goes through the entire list of animals, one item at a time. And on each pass through the loop, here's what we're doing. We're assigning the variable animal to the next value from the list. So on the first cycling through, the first time it runs through, animals called cat, then it's called dog, then it's called monkey. Um, and the colon that we have here at the end tells it that the loop body comes next. So what are we supposed to do within that loop? So as we're cycling through, it wants us to do something. And in this case, we wrote print out animal. So it's going to print the value of the animal. You'll see here that it's indented. So that just explains to you, if you go back and look at the original, that print is indented within the for loop. So that's telling you what the loop is actually, the purpose of the loop is to print out the name of animal one at a time. So this is what it would print out: cat, dog, and monkey. And here's kind of the English, plain English definition of what this chunk of code does. Go through the list of animals one by one and print each one. So that is what this code up here did. So animals, we define the animals, then we start the for loop, and the for loop is just saying, in this variable called animals, the variable is it, what type of variable is it? It's a list. We're going to define each one as animal. And when we do that, we'll print out each one. Then we go to the second one, we print it out. Then we go to the third one, we print that one out. So feel free to use AI in this way to be able to go through and understand what we are doing. I will show you. Let's go back in here, and we're going to go to our Python tutorial here. So let's open up the Python tutorial again. This is the same document that I shared as optional in last week. I do want you to go take a look at it for this week's material. And what I'll do is we're going to walk through some of the pieces here. This is kind of like a textbook that you can use to help you understand what Python is, see some examples. But I'll show you some more of what we have in here so you can see how to do it. Some of this will be repetitive of last week, so feel free to fast forward or skip. But I do walk you through, especially if you're new to this, listen in as we walk through what is in this file. And I encourage you to, again, save a copy of the file. You can always even just play around with this, even though it is not in your own copy of Google Drive. You can still edit. You just can't save anything at the end. So you won't be able to mess up my file, my original file, but you can manipulate it. You can change it around. Let's say instead of 3, you want to call it 5. You can do that. So here I just assigned the value of 5, and we can print out X, but we can also print out type of X. So what type of variable? In this case, it is an integer. You'll see in some of the walkthroughs that look like this. Last week's walkthrough brought you to looking at what types of data we have, things like integers and floating point values and strings. Lists are another one that we just did. Dictionaries we'll see in here as well. So some of the basics. One thing that is unique if you have not used Python before, some program languages use this, but not all. To raise something to an exponent, so like to square something, to raise it to the second, raise it to 2, the second power, you use 2 asterisks. So these, the little multiplication sign, the asterisk. If you use one of them, it's just multiplication. If you put 2 of them together, it is exponentiation. So raising it to the second power. For instance, if I want to cube something, raise it to the 3rd power, same thing that I run over there. So that is to make an exponent. Something else that's useful is to increment something. So right now, if I ask you what is the value of 5, sorry, what is the value of x, your answer is 5 because that was the last value that I put up here. I'll just show you again. It's 5. Even after I run this, the value is still, if we add this in here, print x, the value of x is still 5. What this does is it then takes the value of 5 and increases it, increments it. That's what this plus sign with an equal sign does. It increments it by 1. So if I were to comment this part out and just run these first two lines, x is currently 5, incremented by 1, we get 6. Now if I take this out and actually run this, so now the value of x is 6. I'm going to comment this out because I don't want it to add it again. If I now take this and run this line, this multiplies the value of x by 2, so I'll get 12. If I comment it out, it's actually going to do both. It's going to first now take 12, bring it to 13, then it's going to take 13, the current value of x, and multiply it by 2 to 26. So you can see you can keep incrementing and running this as well. Here you see the exact same thing, but with y, and we can set y to whatever we want it to be. We can set it to 2.5. We can set it to 0. You can set it to 1 and see the differences there. So that is how we can work with some of the data. We have true, false Boolean data right here. So I'm just going to define some variables here as true and false. Then we have some logic statements here. So if you've taken discrete math or logic, you'll go into what some of these things are. So AND requires both of the elements to be true. If the first one is true and the second one is true, then the final output is true. In this case, it's false because one of these is false. Versus OR, where now what we're doing is we're saying if the first part or the second part, if either of them are true, then the whole thing is true. That's what we get here. And then finally, the logical not function is kind of the opposite. So not true, whatever the value of t is, which in this case was true, we set it up here. So the opposite of true, not true, is false. Take a look at this. There's some things about working with strings, looking at the length function. So the length function returns the number of characters in a string. So you have that. There's some different code in here that you can play around with to see concatenation of how we pull things together. One thing I mentioned in last week's video is that strings can use either single quotes or double quotes. You just need to be consistent in each variable. So you can mix and match between sentences. So hello can take single, world could take double. That's totally fine, but you can't do single and double mixed in one. Stay consistent with that. It is nice to stay consistent in your entire project. So feel free to use whichever one is most comfortable with to you. We'll skip over some of this. We'll look at the again, I started this video with uppercase and lowercase. There are some other things here. If you want to just capitalize the first letter of the sentence, so not all caps, but just capitalize the first letter, you can do that with capitalize. So hello world, and you'll see just the first letter of the string is in capital letters here. I showed you lists in that ChatGPT example. From one of these examples, actually, it was as well. So a list is storing 3 separate values, again, in order. So the first element is this one, second one is that one, third one is that. That's where we had the animals. We'll come back to that here in a minute. And what we can do is we can say, I'll show you this. Actually, we'll get to it in a minute. I'll show you how to pull out just one specific number from this. If we want to say, just give me the second number in this list, what is that? And actually, here it is right here. So when we have a number in here, the way that we count in Python is we start counting. I'm going to actually change this to letters. Let's go down to where we had some animals, cat, dog, and monkey. Let's actually replace this. That'll be easier to understand, so we're not worried about. Let's see. There we go. Okay. So we have cat is in the first position, dog is in the second position, monkey is in the third position. If we want to say, just give me the entire list, we can just ask it. I'm going to comment this out. We can ask it print the name of the list. So this list I just called XS. We could call it animals. Yeah, let's call it animals. Okay, so we called this list animals. There's three elements. First element, cat. Second element, dog. Third element, monkey. And if I tell it print animals, it will give us that list of all three. But if instead we wanted to ask for just the first element, the way that we count in Python, which is different than other programming languages. So for instance, if you took my class in R, this is a different way of counting. In Python, we count starting with 0. So 0 means the first position in our list. So the first position in our list is 0, cat. If we say print animals index of 1, that means the second position. So all you need to know is when you're counting the items in a list, for the sake of index position, of which position do you want it to extract? I want it to extract index of 0, which means the first position, index of 1, which means the second position in the list, or index of 2, which is the third position in the list. Again, in R, it's different. In R, we count 1, 2, 3. Here in Python, we count 0, 1, and 2. You'll go on and see different ways that we can store things. In this case, we had names. We could replace the names like I just did. I replaced the numbers with string variables. That's totally fine. So you can mix and match within a list. You can also add something new to the list. So let's say animals, append. So we already had cat, dog, and monkey. Let's say we want to append frog. We can append it to our list and just add in there. Then we can actually just test that and we can say print animals. And here I only want the third position, index of 3, which is the fourth value in the list. And then it did frog. Oh, but you see, because I reran this code that is appending frog to our list, each time I rerun this code, it's just going to keep appending frog into the list. So if you're just testing things out, feel free to comment out your value so that way it doesn't keep doing that. And now it'll just print out the list and it won't keep adding. And again, you can always go back up to the top, rerun what you had. So now my list is back to initializing it again, or taking what I originally had and it's resetting it to that. So now we just have cat, dog, monkey. Now when I print out animals, let me just change this to a 2. I print out animals, we're just stuck with our original. If I ask for this index of 2, which is the third element, it's monkey. When I had index of 3, it gave me this error. And it says list is out of range, list index is out of range because there is no fourth animal in here because I had set this to a comment. So let me rerun this now. Now it's there and the fourth element is frog. And again, if I run it again, it'll put frog back as many times as I run it here. You can continue looking through this. This is just telling you how to work with string values in terms of actually any index. You can slice it of saying, let's filter just this slice of the values. You can see the loop that I pulled before and showed you. There's another fancy thing where you can do index variables. So you can enumerate the numbers one, two, and three to be able to call that. And again, it's just giving it a number for the list to make a numbered list. And these are nice numbered lists, not the 0, 1, 2, but 1, 2, 3. So you can actually count them. Um, Lots of different things that you can do here. You can take a list like this and you can run operations on the entire list by running it as a loop. So just like I showed you the loop before, here we're going to take the number and we will square the number. So raise it to the second power. So you can print the squares of the numbers from this list. Just another way of doing the same thing. And then you can also give it some conditionals. You can say, okay, only print the even numbered squares. This is kind of a fancy way in computer science that we take it based on the remainder after division by 2 to see if something's even or not. So this that I have highlighted here is the fancy programming way of saying something only if it's even. So only if it's even. The even squares from our original list are 0, 4, and 16. I can actually modify this to say only if it's odd, 1 and 9. And the way that I made it odd is just saying not equal to 0. So the remainder after you divide by 2, if it's 0, then that means there's no remainder. So it neatly divides by 2. So like 16 divided by 2 is 8 with no remainder. So 0 was the remainder. So it's even. This is not 0. The answer here is 1. So if I take 9 divided by 2, I do have a remainder. So this is just the way in coding we can say something is odd, the way that I have highlighted here, or if it's equal to with two double equal sign in Python, that means that it is even. We're not going to do anything yet with this, but just to show you, there are dictionaries that you can define. So these are dictionaries that we can then define other elements into. You'll see that in this week's DataCamp tutorial. Here's an example. We had the dictionary, and now we can actually define numbers. So how many legs does each element of this dictionary have? Person has 2 legs, cat has 4, spider has 8, and so on. And then you can write a loop to say a blank has blank legs. So you can format it where you're pulling in the value of the animal name and then the number of legs. Feel free to continue reading on here, and you'll see just some more examples of how to work with dictionaries, how to work with lists, looking at what loops are. Eventually, we'll use different packages, like this is the math package, to do the square root of things. So this is one way that we can do square root. Another way that we can do square root is we can just raise something. Let's say we have x, call it something else. Let's call it z equals 4. So we can do now print z raised to the 0.5. That accomplishes the same thing. Raising something to the 0.5 is accomplishing the same thing as using the fancy square root of z. Oh, there we go. 2. It is best practice to, if you want to print something, to actually put it in a print statement. We can now comment this out because we don't need this anymore. You'll see it did run and it did still print it. In Jupyter Notebooks, it will often print the last line of your code, even if you didn't explicitly tell it to print it. But best practice is ask it to print what you want to print. We'll skip over this for now. You'll see functions here. So this is just defining something that's called a function. In this case, we're defining it, we're calling it sign. So this tool called sign, a function called sign, will just tell us what's the sign of the number that we put in for x. So if we give it a list of X values of -1, 0, and 1, we want to know what's the sign of each of these numbers. Is it negative, 0, or positive? So this is the logic for that. And then we can take this and we can say print sign of, and we can put whatever values we want in here. -300, what does that give us? That gives us negative here. Print sign of 300 gives us positive. Print sign of 0 gives us 0. So again, you have to define that. Sign is not a pre-built function. It's just something that we defined in these couple lines of code, and then we used it down below. Another example of signs making things uppercase or lowercase that you can do. If you get into more advanced courses in programming, like object-oriented programming, this is a great place where you'll go through and learn classes. We're not going to do that in this course. And then finally, I want to just wrap up with some examples from different programs that we'll be using over the next couple of weeks. You'll see these introduced on DataCamp, but this, I've heard it both as NumPy and NumPy, however you want to pronounce it, is a package for scientific computing, so a lot of data work in Python. So you can install that by using this code right here. And then you can look at arrays, which are kind of like lists. So being able to create a list of numbers in here. And you'll see being able to work with the data. So then you can pull in certain data points. Again, you'll see that in DataCamp. But if I wanted to, for instance, to create an array of all zeros, NumPy has a function called zeros. You can set it as a 2x2 matrix, 2x2 array, where you'll create that, versus this here does a 1x2 array. So 1 row and 2 columns. So you have number of rows that you want and number of columns that you have is what we do with these double parentheses in creating arrays. So we can do ones. We can fill in every value of a constant. So let's fill in every value as 7. We can change this to 99, and every value will now be 99. That's what this full does. It just fills in everything. The identity matrix, if you've had that in linear algebra, where you have the diagonal of 1. You'll see that here. And then finally, if you just want to add in random numbers, you can do a set of random numbers. And when you ask for random numbers there, you'll get digits from 0 to 1. So you'll get decimal points from 0 to 1. You can make it a 2x3, which is 2 rows and 3 columns. You can make it a 3x3, etc. So feel free to take a look at this. There's more information on arrays here if you want it. And then down below, here's just an example. You can do arrays with Boolean, true, false digits, true, false data. You can ask it for the type of data that these are. We'll skip array math. And the last thing down here, if you keep going down to the bottom, is some visualization examples with matplotlib. So that is a way of actually plotting out some of your values. So you'll see that we'll spend a lot more time on visualization over the coming weeks, but you can just see that you can zoom in to different information on there. And there is a tutorial I've given you here on visualizing tabular data, so data from tables. If you do want it, you can look at that example here. And this just gives you ways of taking data files and translating them. So this is the inflammation data set. And you can learn more about the data sets on the summary and setup page under episodes here. So that gives you the way of learning about the data and downloading the data. I'll give you a direct link to it as well. But if you do want to play around with this, you can use matplotlib to visualize your data and see some examples from there. We will end the video there. Thanks for sticking with me, and feel free to reach out as we move into next week. Thanks, everyone.